you have a function raised to a power of n. So for example, if I have this composite function, you can think of it as a composite function. You have x cubed and you have 2x plus 1, and you're putting h and x into g at x. Some people say, I don't like this notation. It's just the notation that's used in the textbook, so I need to really show you what this looks like. But always think of it as a function raised to a power. What happens when you have a function raised to a power, right? Because right now we only know how to do x to the power 3. We don't know how to do it when we have a bracket or something raised to the power 3, and that something is more than just x. There are actually two ways of doing this question. One is you can expand this into polynomial function, but that's a lot of work. Nobody likes to do that, especially when this is raised to the power of 10. Like, who wants to expand 2x plus 1 10 times? Not me. So I'm going to bypass that way, even though you can do it that way. I'm like, even expanding to the power 3 is going to take me a while. What we want to do is we want to use what we call the second rule or method, which is called the chain rule. This is the most important rule in derivative. And it's the one where most students kind of like forget or make a mistake. What it looks like is this. If the question, what we had before was, what was it? 3x plus 1 to the power, 2x plus 1, not 3x. 2x plus 1 to the power of 3. This looks like a power rule. So it would make sense if I bring the 3 down, I copy down the function, and I do 3 minus 1 raised to the power of 2. Right? So this would be a power rule. Bring down the 3, the function raised to the power of 2. But because what's inside is not simply x, what you have to do is you have to add the chain. And this is the most common mistake. A student always forget about the chain. Don't forget. What you do is you do the derivative of what's inside only. The derivative of the bracket. Right? This is the last thing we're going to talk about today. The derivative, what's inside a bracket. Well, we can do that. That's actually not hard. It's 2x plus 1. We know how to find the derivative of 2x plus 1. 1 is a constant, so that's going to give me a 0. 2x, it's simply 2. So I'm not going to write the 0 part. So it's just I need to multiply by an extra 2. So the final answer for this question is equal to 3 times 2, which is 6, 2x plus 1 square. Let me try one more. Okay? Let me try one more. If I want to find the derivative of something raised to n power, a function raised to n power, what you do is you do a power rule, but then you have to multiply by the chain. And the chain is the derivative of what's inside the bracket. So here the answer is simply put a 3 down because that's the power. Copy the bracket, that does not change. And then raise to the power of 2. That's the power rule part. And don't forget about the chain. The chain is the derivative of what's inside the bracket. 3x becomes a 3. 1 is a 0. I'm not going to write it. So the answer is 9, 3x plus 1 square. Power rule multiplied by the chain, because this is not just x.